Welcome. This video is for 5 a day questions for A-level Mechanics 1. So coming to the question number 6. So it states that the diagram shows the velocity time graph of a motion of a small stone which falls vertically from rest at a point A above the surface of the liquid. So above the surface of the liquid, it is falling vertically from here. So it is initial velocity is A. Initial velocity is 0 and it is at A. The downward velocity of the stone after leaving A is v meters per second. The stone hits the surface with a speed 7 meters per second. So over here it is 7 meters per second. And so initial velocity is going to be 0, final velocity is 7 meters per second, and the time is 0.7 seconds. The bottom and it reaches the bottom of the container with velocity 5 meters per second at t. So it reaches this is entire thing is water. So it reaches the bottom over here with 5 meters per second, and t equals to, so for that part u is 7 meters per second. For this part u equals to 7 meters per second and v equals to 5 meters per second, and t is going to be nothing but what, 1.2 minus 0.7, which is 0.5 seconds. There are two parts of journey. What is he asking? First part, find the height of the A above the surface of the liquid. So for that, S equals to U plus V by 2 times T. 0 plus 7 by 2 times 0.7, which is going to be 2.45 meters. Now for the depth of the liquid container. So the depth over here is again U plus V. S equals to nothing but what, U plus V by 2 times T. So U is nothing but what, 7 plus 5 by 2 times T. T is 0.5. So which is going to be nothing but how much? 3 meters. That's going to be the answer. Next is asking, find the deceleration of the stone when it is moving in the liquid. So for the liquid part, V equals to U plus AT. So V is nothing but what, 5 equals to 7 plus A times 0.5. So 2 equals to minus 2 equals to 0.5 times A. So A is going to be nothing but what, minus 2 by 0.5, which is nothing but what, minus 4 meter per second square. So when I say deceleration you should be writing it out 4 meter per second square positive. You should not be writing it out negative. Then given that the resistance of the motion of the stone while it is moving in the liquid has a magnitude of 0.7, find the mass of the stone. So for finding that mass of the stone, so you need to remember only one formula has to be done. What is that formula? Forward force minus backward force equals to ma. Forward force minus the backward force equals to ma. The forward force is the weight. What it is? It is when it is moving in the liquid, the magnitude is 0.7. The forward force is the weight mg minus the backward force is the force, which is it is pushing it upwards, and this is the weight equals to ma. M is nothing but what, we don't know, and a is minus 4. So mg minus 0.7 equals to ma. So mg is nothing but what, 10 minus 0.7 equals to negative 4m. So 14m equals to 0.7. So m equals to 0.7 divided by 14, which is 0.05 kgs. That's going to be the answer. Now coming to question number 7. A particle is P is of mass 0.6 kgs is projected vertically upwards with a speed 5.2 from a point O, which is 6.2 meters above the ground. So this is 6.2 meters above the ground. This point is 6.2 meters above the ground. This point is nothing but what, O, and we are projecting a particle P. And what is it? It is initial velocity is going to be 5.2. So U is going to be 5.2. Air resistance P acts in deceleration is 10.7. So air resistance is acting, so the deceleration is minus 10.4 meter per second square. Next, when P is moving upwards and its acceleration is 9.6 when P is moving downwards. Whenever it is coming downwards, its acceleration is going to be nothing but what? Plus 9.6 meter per second square. The greatest height above the ground which it reaches. So, in case of greatest height, we know that maximum height formula is going to be u square upon 2g, which is nothing but what? 5.2 square upon 2 times 10.4. 2 times 10.4, that's going to be giving me the answer as 7.5. That will be the answer for it is 7.5. So we need to use the formula for the maximum height. The maximum height formula is going to be u squared upon 2g, 2 times 10.4, which is going to be 7, which is going to be 1.3 meters, not 7.5. But what is he asking about the ground? So we need to add this one 6.2 meters also. So which is 6.2, which is going to be 7.5 meters. So maximum height is reached by it is going to be, it goes like this. This height is going to be 1.2 meters, 1.3 meters. So the total height is going to be 1.3 plus 6.2, which is 7.5 meters. The speed with which P reaches the ground. Now, for the downward journey, it will be traveling. So U equals to 0, and it will be traveling the distance of 7.5 meters. V equals to question mark, and acceleration equals to 9.6. So V square equals to U square plus 2AS. So which is 0 square plus 2 times 9.6 times 7.5. So V will be square root of 2 times 9.6 times 7.5, which is going to be nothing but how much? If I do by calculator, 2 times 9.6 times 7.5, which is going to be 12 meters per second. The total work done by on P by the air resistance. So what is the total work done by P by the air resistance? For this one, what we are going to do it is total work done equals to delta KE, delta change in the kinetic energy plus change in the potential energy, change in the kinetic energy by plus change in the potential energy minus work done against friction. So there is no friction at all, so we don't consider over here. So this is the formula you should be remembering: total delta kinetic energy plus delta potential energy minus work done against the friction. So delta kinetic energy, what is delta kinetic energy? Final kinetic energy minus initial kinetic energy. That is going to be the, what is this, delta KE. Whereas what is delta PE? Delta PE is final potential energy minus initial potential energy. So first of all, final kinetic energy is half m. M is nothing but what? How much is the mass? Mass is 0.6. Half m 0.6 v square. Final velocity is mv. 12 minus half 0.6 and initial velocity. What was the initial velocity? We are throwing it up with 5.2 square plus final potential energy is going to be 0 because it is on the ground minus initial potential energy is 0 mgh. mgh, h is going to be nothing but how much? 6.2 times 6.2. So if at all I simplify this one, so times 12 square minus 0.5 times 0.6 times 5.2 square, and then plus 0 minus 0.6 times 10 times 6.2. This should be giving me the total work done is nothing but what? Minus 2.112 joules. But it is work done against the friction. So therefore, what am I going to do it out? My final answer is 2.11 joules. So don't write it out in negative answer. So write it out in the positive. So final kinetic energy minus initial kinetic energy, final potential energy minus initial potential energy should be giving you the total work done. So you should be able to remember this formula for calculating the total work done. Now coming to question number 8. Question number 8 is about a velocity time graph. The diagram shows the velocity time graph for the motion of a machine's cutting tool. The graph consists of 5 line segments. The tool moves forward for 8 seconds while cutting and then takes 3 seconds to return to the starting position. So it takes 5 seconds to go forward and coming backwards is nothing but what? 3 seconds. So let's try to solve it out. The acceleration of the particle for the first 2 seconds. So for the first 2 seconds, initial velocity is going to be 0, final velocity is 0.18, time equals to 2 seconds. So V equals to U plus 80. 0, V equals to 0.18 and time equals to 2 seconds. So V equals to U plus 80. So 0.18 equals to 0 plus 2 times A. So A equals to 0.09 meter per second square. The distance of the tool moves forward while cutting. So the distance, what is it move while cutting? So it is going forward for how many seconds? 8 seconds. So this part, this is the trapezium. So we have to find it out the area of the trapezium. So that is for part 1, and for part 2 it's going to be 1 upon 2 times 8 plus 4 times 0.18, which is going to be 1.08 meters. That's going to be the answer. The greatest speed of the tool during the return to its starting position. So this area is also going to be nothing but what? 1.08, because how much forward? It's going forward, it coming backward the same decision, same distance. So backward is also is going to be same 1.08 meters. So the area is going to be 1.08. So for third part, the distance is going to be nothing but what? It is the same 1.08 meters. So it's the area of a triangle. Half times base. Base is how many seconds? 3 seconds. 3, and the height is the maximum height is velocity v equals to 1.08. So this gives me v equals to 0.72 meters per second. Now coming to question number 9. A train starts from rest. So it is about nothing but what? A train. A train is starting from rest at a station A and travels in a straight line to station B, where it comes to rest again. The train moves with constant acceleration for the first 600 seconds, with constant speed for 2600 seconds, and constant deceleration. Acceleration, speed, and then deceleration. That is what is being told. So we will draw a velocity time graph for that. So for how many seconds? 600 seconds. Then with a constant speed for the next 2600 seconds. So 2600 plus 600 is 3200. And finally constant deceleration. Now this is time and this is velocity, which is meter per second. And origin O. The total time taken for the train to travel from A to B. So for the first one, for the first part, initial velocity is 0, final velocity we don't know, acceleration is 0.025, and time equals to nothing but what? 600 seconds. So we find v equals to u plus 80, so which is 0 plus 0.025 times 600, which is going to be nothing but how much? 0.025 times 600, which gives me 15 meters per second. So this velocity is going to be 15. Over here, the velocity is 15. Now, for the final part, the velocity, initial velocity is going to be 15 and final velocity is going to be 0. So initial velocity is 15, final velocity is 0, deceleration we don't know. Then the deceleration we know. How much was the deceleration? 0.0375. 0.0375. So time we don't know. So we can use V equals to U plus 80. V equals to U plus 80. 0 equals to 15 minus 0.0375. Why it is minus? Because it is deceleration. So minus. And the time is T. So that gives me T value as 15 divided by 0.0375. So 15 divided by 0.0375 gives me nothing but what? 400 seconds. So total time is going to be 3,200 plus 400 is 3,600 seconds. So the total time is, already it was 3,200 plus another 400 seconds for deceleration, which is 3,600 seconds. Sketch the velocity time graph for the journey for the distance AB. We have already done. Then next, what is he asking? The speed of the train T reaches after leaving A is 7.5 meters. State the possible values of T. So the maximum speed was 15, but it reaches 7.5. So this one is 7.5 at what times? It is at T1 and it is at T2. What are the two different times? He is asking us to find it out. So, and it's going to be 1 mark over there. So 7.5 meters per second. That should be the speed after leaving A. So there are multiple ways of doing it out. So for the first part, u equals to 0, final velocity is 7.5, acceleration is going to be 0.025. Then, so what's going to be the time? So v equals to u plus 80. I'm going to use v equals to u plus 80. So, which makes me to get 7.5 equals to 0 plus 0.025 times t1. So, which is 7.5 divided by 0.025, which is going to be t1 is 300 seconds. Now, while coming backwards, so u equals to 7.5, v equals to 0, deceleration is minus 0.0375, then time equals to t2. So, v equals to u plus 80, 7.5 minus 0.0375, t2. So T2 is going to be 7.5 divided by 0.0375, which is going to be 200 seconds. So, but the total time was 3,600. 3,600 minus 200. So, which is going to be 3,400. So, the final answer is going to be 3,400 seconds. And the last question for today, day 2, will be again a velocity time graph question. The velocity time graph shows the model of the motion of a parachute falling vertically. These are 4 stages: falling freely with the parachute closed, falling freely, the decelerating part, falling with constant speed, and coming to the rest of the ground. Total distance traveled, show that the total distance traveled is 1048 meters. So we have to show that the total distance traveled is 1048 meters. So for that, I am going to first find it out the area of this triangle. Area of the triangle is half times base times height. Height is going to be 50. Half times base times height. Then plus. This is a trapezium. The blue color one is a trapezium. This part, this part, this part, and this part. So trapezium. For that, it's going to be half times distance. What is the parallel side? So it's going to be 8. One parallel side is 8 and another parallel side is going to be 50, and the distance between them is going to be 7. Then I am going to find the area of this rectangle. Length times width. The length is going to be nothing but what? 90. 90. Why this length is 90 and this height is going to be 8. 90 times 8. So add them all. You are going to get it at 1048 meters. Then the weight of the parachutist is 850. The upward force of the parachute. Find the upward force on the parachutist due to the parachute during the second stage. In the second stage, he is asking us to find it out. So the weight is. So we know that forward force minus backward force equals to ma. Forward force minus backward force equals to ma. The forward force is going to be nothing but what? The weight. The forward force is the weight, which is 850. Then minus the backward force is going to be nothing but what? The upward force, which is F, and equals to nothing but what? Ma. The mass is nothing but what? Mass of the parachutist. So now we need to know the mass of the parachutist. Then has he given any here the mass? It is 85. Why it is 85? Because the weight is nothing but what? 850. 850 equals to 885 mass times g. Mass times g. But g is nothing but what? 10. So mass is going to be 85 newtons. So we need to calculate the acceleration. For the second stage, we need to know the deceleration. So for the second stage, the deceleration is, we shall do the deceleration over here. So initial velocity is going to be nothing but how much? 50, and final velocity is 8, and the time is nothing but what? 7 seconds. So v equals to u plus 80. So 8 equals to 50 plus a times 7. So what does that becomes a? A equals to 8 minus 50 divided by 7. 8 minus 50 divided by 7. So minus 42 divided by 7, which is going to be 6. Negative 6. So I get that answer as 850 minus, or let me write it out in a fresh page so that it will be easy for to understand. So what are we doing to do it out? Forward force minus backward force. Forward force minus backward force equals to ma. The forward force is going to be the weight. Backward force is going to be the upward force, and ma. So now the weight is 850 minus F equals to mass is 85, and deceleration we don't know. So let's calculate the deceleration. U equals to nothing but what? 50. V equals to what is this? It is 8, and time equals to 7 seconds. So V equals to U plus 80. So 8 equals to 50 plus A times T. T is 7. So 7a equals to minus 42, a equals to minus 6. So from there, if I plug in 850 minus f equals to 85 times minus 6. So what is that? So f is going to be nothing but how much? 850 plus 85 times 6, which is going to be 1360 newtons. That's going to be the answer. So that completes day 2. See you in the next video for day 3.